let's learn how to name alkanes, especially alkanes that have complicated branching systems, right? So we can use the systematic process IUPAC, International Union of Pure and Applied Chemistry, just a union of chemists that came up with these names for how to name organic compounds systematically. So anybody, if they're following the IUPAC rules for any one molecule, any chemist should come up with the same name for it. That's the whole point, a way to standardize naming of organic compounds. So here's our compound that we're naming, a large branched alkane. These are the rules, and they're pretty simple, hopefully. Find the parent hydrocarbon chain, which is the longest continuous chain of carbons. Don't be afraid of turning corners. The longest chain will not always be the one that's just drawn straight left to right. Be careful that you're just counting from one end carbon to another end carbon, turning corners as you need to, but never lifting your pencil. So if I counted just the straight ones here, it's 1, 2, 3, 4, 5, 6, 7. But if I count going up this branch here, I got 1, 2, 3, 4, 5, 6, 7, 8. So that's the parent hydrocarbon chain. We number that chain, number the atoms on that main chain, starting with the end that's nearest to where a branch is. So I've got the left side and the right side. On the left side, 1, 2, 3, 4 is where the first branch comes. But from the right side, 1, 2, 3 is where the first branch comes. So 4, 5, 6, 7, 8. Very consistent in organic chemistry is the fact that we will number compounds so that the numbers we give will be as small as possible. That's why we number from the side that's closest to a branch. That'll make our numbers smaller. If there's ever a tie, if there's ever, say, 2 different 8-carbon branches, pick the one that has the most branches. So if there are 2 with the same number of branches, that gets more complicated than we'll be dealing with right now anyway, but there are ways to rectify that. So if we're tied at the direction from which we are numbering, we look for the nearest second branch in. So if we've got branches 2 carbons in from either end, then we look further on. So if there's one right next to it on one side, but then not the other side, then we'll know to number to the side closest to the one with the next branch to it. Let's identify and number substituents, calling them alkyl groups, the way that we did on the previous page. So the substituents are anything that are not part of the main hydrocarbon chain. So I have a CH3 attached to carbon 5, and then 2 CH3s attached to carbon 3. Remember, those CH3s are called methyl. We number the substituents based on what number on the main hydrocarbon chain they're attached to. So this one on top here is a 5-methyl. Both of these are called 3-methyl. That number, by the way, is called a locant. L-O-C-A-N-T. You're going to see that word used to describe parts of naming. So a locant is just a number we use to describe where a certain fragment of a molecule is located. Okay? So we've numbered the substituents. We name molecules as a single word. Almost all organic compounds are named as just one word. There are a couple of functional groups we'll talk later on that have 2-word names, but otherwise everything else is just one word, no spaces. If we have multiple identical substituents, we're going to use multipliers like di, tri, tetra to show that I have 2, 3, 4 methyl groups or so on. So here I have methyl groups. I have 2 of them on carbon 3 and 1 on carbon 5. So I have 3 methyl groups total in the molecule. And if you have different substituents, you'll alphabetize them with the substituent names, but these multiplier prefixes don't go for alphabetizing. So I'll have trimethyl. I'm going to use numbers to indicate where all of those are located. So I'll include 1 locant for every substituent in the whole molecule. And use hyphens to separate a number and a letter. Use commas to separate 2 numbers. So I need 1 locant for each of these 3 methyl groups. So I have to do 3, 3, 5, because use commas to separate numbers. And then 3, 3, 5 trimethyl. So I'll use a hyphen and see. trimethyl, because here we're separating a number and a letter. And then we name the main parent hydrocarbon chain. In this case, there's 8 carbons. 3,3,5 trimethyl. Parent hydrocarbon is octane. So name of this compound, 3,3,5 trimethyl octane. Notice no space between the last substituent and the main chain. No dash, no nothing. Separating 2 letters from each other, those just blend into the same word. We used hyphens here because we're separating a number and a letter. So you can feel free to practice those with the examples in the textbook and in the online homework. Let me just, for sake of illustration here, give you a much more complicated example. Especially in this one where our main chain has 9 carbons. They've already numbered these for you. But then there's a complex substituent coming off of carbon 5. There's a branch on carbon 5 that has its own branches. So that's okay to do as long as we've correctly identified the longest chain, and we have. We can't go 1, 2, 3, 4, 5, 6, 7, 8. Right? We get 8 if I start going into this other branch over here. So if that's the case, we number this one, this complex substituent, as if it were its own compound. So the key to this is to start numbering on the carbon that's attached to the rest of the molecule. So even if that's not the end of a whole chain, we have to start numbering it there. So that's carbon 1, carbon 2, carbon 3. And then we name substituents coming off of that. So this one is called, this little subunit over here is called 1,2-dimethyl. If not for those methyls, this would be a 3-carbon branch. That would be propyl, right? So this is 1,2-dimethyl propyl. That's just this substructure in there. So we're going to name the whole molecule using that substructure as just one of the branches. So the only other thing I have in here is the methyl group. It turns out that the di, the D in this one, does get alphabetized, but only do that when we've got a substructure. This substructure then goes in parentheses. So I'll call this whole thing 5 as the locant of this substructure, because this whole big thing is attached to carbon 5. So 5, and then in parentheses, give that substructure name. So 1,2-dimethyl propyl. Then the rest of the molecule. So 2-methyl. And then 9-carbon chain, nonane. So we have the substructure that came off of carbon 5. I number the substructure always from the carbon that's attached. So carbon 1 is attached. So I have 2 methyl groups attached to carbon 1. 1,2-dimethyl propyl. We end the propyl. It's not 1,2-dimethyl propane, because that would be a complete molecule. This is still a molecule fragment, so still ends in YL. That substructure gets set off in parentheses inside of the main name, but it's attached to carbon 5 of the main backbone. So there are other examples of this in the textbook that you can use to help you become a little more familiar with this, because this is something that's not always covered in introductory or general chemistry classes that we sort of add on at this point. But that only happens in fairly complicated molecules where you have to do that substructure naming.